Alright, here's our second video about variation. And direct variation, I just want to say, is extremely common. I want to give you a bunch of examples where it shows up. Direct variation, by the way, is also called proportionality. I didn't mention this in the first one, but it is true that the word proportional, just in everyday English, as long as you're being precise about it, is proportional, means the same thing as varies directly with. So, in other words, the ratio is constant. So, if you're talking about here's one example. If you're talking about a line, we know that one property of lines is that the slope is always the same between any 2 points. So in other words, the change in y divided by the change in x always gives you the same number. And if you just multiply both sides of this equation by delta x to move it over, you could write it like this, which is the definition we had before of direct variation. Just remember what that is. It means you can write it as y equals k times x, where k is a constant. So in this case, the change in y is directly proportional to or varies directly with the change in x. Another example, let's say you drive at a constant speed of 30 miles per hour, meaning you don't hit the gas, you don't hit the brakes, you just go that speed. Then the distance that you go, number of miles, is going to be equal to 30 miles per hour times the number of hours that you go at that speed. This is just distance equals rate times time as an example of that. So you can say that when you drive at a constant speed, your distance varies directly with the time that you drive. Another little economics example is, let's say there's a country with 20 million people in the country. Then if you want to talk about the total gross domestic product, I'm not going to get into what that means, but it's like the total amount of money that was spent in the country. That number is 20 million times the per capita gross domestic product. So those are numbers that are thrown around in economics. This per capita means per person. So this is like the GDP that goes with one person. If you multiply that by 20 million, you get the total GDP. Simple geometry example is if a circle has diameter d and circumference c, then pi is the constant of proportionality here. The circumference is always pi times the diameter. So these are just a few examples, but you can imagine that this kind of simple equation where you have y equals some number times another variable, x, it's really common, and you've seen a lot of examples of it before. Now, one thing I want to remind you of really quick is that you could take this equation and just divide both sides by x, and if you do that, it's equivalent to y divided by x as a fraction is equal to k. And this is what we're going to use if you want to determine if you have values of x and y and you want to plug them into something, you want to see if it's direct variation, use this. And here's an example of that. If you've got some kind of description of a situation like this, and you want to know if this is direct variation. So the first question here says proportional to, and let's remember that proportional to means the same thing as varies directly with. So that's what we want to check. Is there a number k so that you can multiply k by the number of units and get the tuition at Woodrow University? I'm going to use the variables t for tuition, dollars, and let's say u is the number of units. And this describes a linear equation because it starts out at a certain number if you take 0 units, but then it increases at a constant rate. So we're going to say that the equation for this is t equals 400 plus 30 times u. That's just like from chapter 1 when you have a linear equation, and it gives you a starting value and then a rate that the tuition increases as u increases. So we got that. If we want to use this, I mean, you might be able to tell right now, this does not look like t equals just a number times u, because it has the 400 there. If it was just t equals 30u, we'd say yes. But let's actually just check that this doesn't work with this. Like, how does the 400 mess up this proportionality thing? So we can make a small table of values for this that we can plug in here. So for example, if you just take 1 unit, then the tuition is going to be your $400 plus the $30 for the 1 unit. If you take, I don't know, let's say 6 units, your tuition is going to be $580 if you plug in u equals 6 here. If u is 10, let's say, we're going to have $700 total. So if we just calculate t over u with this first one, here 430 divided by 1 is 430. Here 580 divided by 6 is 96.67. And 700 divided by 10 is 70. So yeah, these numbers are very different. So we can definitely answer this question and say that t does not vary directly with u. Let's look at part B now. It says that Imogen makes, I think that's how to pronounce that name, Imogen, makes a 15% commission on her sales of environmentally friendly products marketed by her co-op. Do her earnings vary directly with her sales? So let's see. Let's say that for part B here, that her earnings, let's just call that E. So let's figure this out. How can we write an equation about this? It says she makes a 15% commission. What that really means is that her earnings are 15% of the stuff that she sells. So in other words, her earnings are her earnings are equal to 15% of the amount she sells, which is X. So we could also just write that as E equals 0.15x. And that means, yeah, this is a direct variation equation. It's of this form y equals kx. So we can say yes, and the constant of variation is 0.15, also known as 15%.